Sir Isaac Newton was an English mathematician, physicist, astronomer, theologian, and author. Newton is renowned for his many scientific contributions, including the three laws of motion, the first being the law of inertia, the second stating that force equals to mass multiplied by acceleration, and the last is that every action has an equal and opposite reaction. Each law of motion that Newton developed has significant mathematical and physical interpretations that are needed to understand the motion of objects on Earth. Simply, they describe the relationship between a body and the forces acting upon it, and its motion in response to those forces. We'll begin with defining key terms. So what is motion? In physics, motion is the change in position of an object with respect to its surroundings in a given interval of time. Motion is mathematically described in terms of displacement, distance, velocity, acceleration, time, and speed. What is a force? A force is any interaction that will change the motion of an object. It can also be described as a push, pull, or twist. Force cannot be possessed by an object, rather it is exerted onto it by another, causing a change in motion or shape. All three laws can be observed everywhere, for instance, in a game of hockey. Newton's first law states that an object will remain at rest or in a uniform motion in a straight line unless acted upon by an external force. This is also known as the law of inertia. Simply, inertia is the resistance of any physical object to any change in velocity. The puck in this scenario is being acted upon by balance forces, which are equal forces acting in opposite directions. In this case, the forces of gravity and the floor allow the puck to remain in a stationary state. The velocity remains unchanged. Newton's second law of motion states that the acceleration of an object is dependent upon two variables, the net force acting on the object and the mass of the object itself. In simple terms, the law states that force equals to mass times acceleration, or F equals m times a. In this scenario, the hockey stick acts as an opposing or external contact force as it strikes and starts the puck in motion. The puck then accelerates at a speed dependent on its mass and the force applied to it. Basically, force is directly proportional to mass and acceleration. For example, if the weight of this puck is 170 grams and accelerates at a speed of 2 meters per second squared, then the force would equal to 170 times 2, or 340 newtons. If the force applied to the same puck increases, the acceleration of the puck will also increase. Newton's third law of motion states that for every action there is an equal and opposite reaction, meaning that in every interaction there is a pair of forces acting on the two interacting objects. These two forces are called action and reaction forces. In this scenario, the force of the puck accelerating into the net is the action force. The equal force that the net exerts onto the puck, causing it to bounce back, is the reaction force. The action-reaction force pair causes the previously accelerating puck to rebound and travel in the opposite direction. It will eventually come to a stop due to friction, the resistance that one surface or object encounters when moving over another. So, in summary, Newton's three laws of motion are present everywhere and can be observed in many activities from walking to launching a rocket, and are an integral contributor to our overall understanding of the mechanics of Earth.